want to move this out of the way. Oh, there. All right, so we're going to look at why do the layers of Earth move over time. So when we first started talking, we said the Earth has layers. Then we did some notes and we said this is what those Earth layers are. Then we started looking about how over the last, billions of years of our planet, those Earth's layers, the top two layers, crust and lithosphere, has been moving. And now we're going to be talking about why they're moving. So 4.6 billion years ago, Earth formed as bits of material collided and stuck together through the process called accretion. The young planet became a glowing ball of melted rock. In time, more dense materials such as iron and nickel sank towards the center of our planet, and less dense materials moved towards the surface. Earth's main, Cooper, please don't be on your phone. Earth's main material layer or main layers formed the core, the mantle, and the crust. So we need to talk about this word density. And is density one of your vocabulary words? So density is a word that we use to describe how much space an object or substance takes up. So we have to look at its volume in relation to the amount of matter or atoms in that object or its mass. So Easton was right when he started talking about this idea that we have, it's the amount of atoms or matter that are in something. But we also have to think about its volume, okay, which is the space it takes up. So we're going to put a box, please, around this word density on your lab. And then we're going to circle this word mass, and we're going to circle this word volume and connect the two with an arrow. If we want to figure out an object's density, you have to know the mass of the object, meaning how many atoms are in that object, and the volume of that object, meaning how much space that object takes up in the universe. For example, if you wanted, well, we'll just move on. Today, we're going to investigate the properties of density using water displacement. Okay, so water displacement is something that we're going to be talking about. Come on, Pat. Water displacement. And if I wanted to figure out the volume of an irregular object, which a lot of things in the world are, like Mrs. McGrain, we would have to use water displacement to figure out how much space I take up in the universe, because you can't measure all of my parts. So water displacement is like this. If you take Mrs. McGrain and you put me in water, let's imagine that this is 10 liters of water. You're not writing any of this down. I'm just showing you what water displacement is all about. Then you put Mrs. McGrain in the water and you have to fully submerge Mrs. McGrain in the water. What is going to happen? Cole, this one's for you. What's going to happen to the level of the water once you put Mrs. McGrain in? It's going to rise. Yeah, there's no trick question here. It's going to rise up. You're going to have a new level of water. Let's imagine that this level of water is now 14 liters. So I went from 10 liters up to 14 liters. If this was true, what is the volume? What is the space of Mrs. McGrain? Coop. How did you figure that out? Yeah. So we would say that the volume, the amount of space I take up, is 4 liters. Because the water raised up, it was displaced. My body was in there pushing the water out of the way so that my body fit, and that raised the level of the water. So that's how you figure out what the volume of an irregular object like me, or my phone, or this remote control. Okay, so that's how we do water displacement. When we are measuring the mass, that's measuring the amount of atoms in an object. So we use what's called a mass balance. It's basically an electronic scale, but we measure it in grams for small objects, kilograms for large objects. But when you mass something, you are trying to figure out how many atoms are in that. And we measure the amount of atoms in grams or kilograms. Okay, so that's what we're going to be doing today. You need to click on this link. Now, you can't click on it, but you can go unless you have an electronic version of it, you can go ahead and go to our Canvas. So let's see if I can get our Canvas open. And if you look at today's Canvas, this is our density lab if you want an electronic version of this, but you're going to click right here on the lab link. Notice I have posted our vocabulary quiz for you to work on today or tonight. So when we open up our lab link, you should be able to see a density lab at PBS, and then you're going to launch it. So you go ahead and launch this, and we're not going to start the lab yet. We want to make sure everybody is where we are. Is everybody here? Easton, are you where you need to be? Mm-hmm. Yes? Mm-hmm. Yes? Not yet? Yes? Coop? Yep. Corey? Good? We're good? 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 Well, okay. So if you look, let's go ahead and play for a little bit. This block I can take out and I can drop in. And notice it's kind of floating in this fluid. I don't know what this fluid is, but the density of the fluid is 2.5 grams per milliliters, which means nothing to you right now. But is this block, because it's floating, more dense or less dense than the fluid that it's in? I already heard from you. I already heard from you too, Coop. Corey, what do you think? Do you think that this block, since it's floating, it's not sinking, is it more dense or less dense than the fluid? It is less dense. Nice job, man. It's less dense because it's floating. Let's go ahead and on this bar over here, what did you do, dear? My block. Okay, so you see this button that says reset? So let's take this green button right here and let's try to make the block sink. What do you think we need to do in order to make the block sink? Do we make the fluid even more dense? That's not working. Let's try to make the fluid less dense. So now I've decreased the fluid's density and I've made it so that the block is more dense and it sinks to the bottom. You got me? Let's see if we can increase the mass. I'm going to move the fluid back a little bit so it floats. Now let's see what happens if we make the block more massive, meaning we're putting more atoms in there. I'm not changing the space that it takes up. Notice the shape is still the same, the size, but I'm going to make more mass. That means that now that block has more atoms packed into it. The space is still the same, but there's more atoms. What happens if I change the volume now and I make it more, ooh, wow, that's large. Whoa. So now it's bigger, right? It's taking up more space. So just because something's bigger, that doesn't mean it's going to sink. It doesn't mean it's going to sink. So just because you have more mass, or rather just because you have more space, it's a larger object, doesn't mean that you necessarily have increased its density. All right, so let's go ahead and look at our lab, please and thank you. We're going to choose 2 substances from the list and fill them in the space provided. So I want you to choose 2 of those substances from our lab. You get to choose any substance that you want. Yep. Yes, absolutely. I'm going to reset my screen so that mine is reset. Can I just give it to you forever? Because I can't take it back from you. I'm going to gently toss this to you, and we're going to hope that it does not break the lead. I'm sorry, I just threw a sharp, pointy object at a student. So bad. So here are your choices. You're going to choose gold, iron, wood, lead, foam, rubber, ice. Don't worry about the mystery. The mystery is if you want to work on that over break, you can try to figure out what the mystery is. But right now, pick 2 of those and put it in your table. Could you please raise your hand when you have 2 of these objects filled into this table? Fabulous. And so the table that I'm talking about is right here. Oops, which you can't see now. So you're going to put something here, like maybe if you want to figure out, I don't know, wood, and you want to figure out rubber, or whatever. I don't care. You choose what you want to choose. Don't choose mine, please. Now, let's go ahead before we move on at all. We're going to write a hypothesis. Look at right down here. Test question, which subject has a greater density? I think that substance, what? Wood has a greater density than substance rubber. You write down on yours, please, and raise your hand and let me know when we're ready. Good, good. Corey, you got that written down? Yes? Carly's working on it. She's looking good, good. You're good, great. So now we have two. So I'm just going to guess, I don't know. I'm going to guess that rubber has a greater density than wood. I don't know if I'm right or wrong. Now, mass is how much matter or atoms are inside an object. You're going to use the virtual electronic balance to measure and record, meaning write, the mass of each substance in the table. So how do we do that? Let's go back. And I think I said rubber. So I need to take this and pull it out of the water and drop it onto my scale. Don't forget the unit labels because we need those when we are figuring out our unit for density. Okay, and then I think my other one was wood. So let me change it to wood. 1.95 grams. All right. When we are ready to test volume, let me know. Raise your hand if you're finished with your mass. And if you want to move on, by God, you move on. But I'm just going to go ahead and wait for the rest of us that move at a little slower pace because I do sometimes. Okay, so volume is how much space something takes up. In science, we often use water displacement to measure an object's volume. You need to take the block out of the liquid, which we did, and enter the level of the liquid when no block is in the beaker in space B below. So we're going to put our first measurement when there's nothing in the beaker right there. So I have 25.5 milliliters. Does anybody else have that? Unless you changed it into water, but I'm just keeping mine what it is. So I'm going to put 25.5 milliliters. Don't forget to put milliliters. Okay, now place the block into the liquid and enter the new level of liquid when the block is in space A. So I'm going to take my block of wood. Oops. I'm going to drop it in there. Now I have a problem. What's the problem with my block of wood? Is it all the way submerged? No. So what can I do that we did in the beginning in order to get this block of wood to sink down? That's right. I'm going to go ahead and change the density so that now my fluid is less dense and the block sinks. And now I can see what my level is because you want to make sure that you're fully submerged. Okay, now we subtract. 28.5 minus 25.5, that's mine. You do yours. So I'm going to use my calculator. I don't need to, but it's good modeling. I get a volume for my block of wood of 3 milliliters. So I'm going to say 3 milliliters up here. Hi, dear. You're doing a lab. So it's okay. 3 milliliters. You're going to then do the same thing for the next substance. So you're going to need your Chromebook. Oops. So I think mine was this. Okay. And go in your Chromebook to Canvas, and you're going to click on the lab link. Okay. So density is found using the mathematical model M divided by V, or mass divided by volume. So now you're going to calculate the density of each substance and record in the table above. So I'm going to start with mine, which is wood. I'm going to take my M, which is my mass, and put it into my calculator, 1.95. Then I'm going to hit divide. You can use your phones if you need to. Then I'm going to divide by my volume, which is 3. And I'm going to get a density of 0.65. Now I need my unit labels. Unit labels are going to be grams, because that's my mass, divided by milliliters. Okay, so I'm going to show you what to do. These are mine. These are not yours.
Oh, okay.
That's okay. Let me show you exactly what you need to do. So go ahead and calculate your next density. So honey, are you at the lab?
Yeah.
Great. So then did you launch the lab?
How do I know? Okay, yeah.
Okay, so now what you're going to do is you are going to choose 2 of these objects: gold, iron, lead, wood, foam, rubber, whatever it is you want.
And do I click on them?
Nope, you're not. You're just writing them down in the table.
Okay.
Okay, so now what you're going to do is you are going to just click on one of them. Like, which one did you turn it into first?
Gold.
Okay, now you're going to take it out of the water and drop it onto the scale to see how much the mass of the gold is. So you're going to follow the rest of those calculations, or the rest of those instructions, see what you can do, and then watch this recording later on, okay?
Okay.
Yeah. All right, my little ones. So I'm going to go back. So your challenge, if you want, sometime over break, is to figure out what the density, or excuse me, what this mystery is right here. Can you figure out this mystery? So what information, what variables would you need in order to figure out what that mystery object is? What would you need to know about that object? Yeah, Cooper.
The mass.
You need to know the mass. What else would you need to know about that object? You'd need to know the volume. And then you'd need to go ahead and compare it to one of these and say, oh, I think that this green thing is foam because it's got the same density. Do you see what I'm saying? These are the knowns that we can figure out, and then we can compare against an unknown. Yes, dear?
So it's one of those?
I believe it's one of those. Okay, we're not doing that right now though, bud. Right now what we're doing is we're going to take some notes on the back. Are you stuck?
Yeah. What do I write for, like, how do you find the volume and the density?
So did you look down at first, before you move on, you're going to try to figure out which one of those do you think has a greater density than the other. Do you see the hypothesis?
Oh, yeah.
Yeah. And so all the steps are right there for you.
Awesome.
All right, so let's go ahead and move to the back, please. We're going to take some notes right now, and we are going to take some notes on density. You're done with your Chromebook, my dear. Thank you very much for asking. So our essential question today is, how does density affect the movement of the crust? How does density affect the movement? Because we said that it's about density. And so that kind of, that same question is what we started class with. If you were in New York City, would you want to live on the top level of a building or not? And so we're talking about, why is it that fluids move? So the first thing that we need to talk about when we talk about these notes is, what is density? And density describes how much mass is in a given volume of material. So density equals how much mass is in a given or a certain volume. So again, there's two variables we need to be thinking about. We need to think about the mass, meaning the amount of atoms that are in that object in a certain amount of volume. Because if we think back to what we did with our lab, I found out that the density of wood is 0.65 grams of atoms. That's how many atoms? 0.65 grams of atoms per 1 milliliter. So in 1 milliliter of wood, I have 0.65 grams or 0.65 atoms of wood. You understand what I'm saying? If this was a milliliter, a volume of milliliter, this would be the amount of atoms in there. Or if this was a milliliter, see the amount of atoms in there. Which one has more atoms in the same space?
The one on the right.
Yeah, this. So which one is more dense?
The one on the right.
This, because there's more atoms in the same space. Less atoms in the same space. Okay? When we are talking about density, we're talking how many grams of atoms in a certain volume. That's why we write the unit label as such. Grams per milliliter. Grams per 1 milliliter. And at this point, I should probably tell you that 1 milliliter equals 1 centimeter and equals 1 cc. These are all the same volume. They take up all the same space. 1 cubic centimeter means that I would have a cube that's a centimeter by centimeter by centimeter by centimeter by centimeter. That's what that means. Each side is a centimeter. Vicky, how am I doing on time? Yes, Vicky, 15 minutes. Okay, so density is how much mass in a given volume. We need to remind ourselves that mass equals the amount of matter or atoms. That's what the mass is. Okay, in an object. How about that? I say in an object. In an object. Like Mrs. McGrain. Okay, volume is the amount of space Mrs. McGrain takes up. Amount of space an object takes up. I have a certain volume because I occupy a certain space in the universe. My space in the universe is my volume. Awesome. Density of matter. We need to look at all of these. We know that gas, oops, that's not how you spell gas, gas, liquid, and solids, they're forms of matter. Okay, that's really important. So all matter. And if they all matter, then they all have density. Awesome. So let's go ahead and look at what the densities look like. If we have, notice the volume is all the same. So I'm going to say same volume. The same volume is in all of these. And that's because, look at the little box. The box is all the same. So does gas have more or less atoms in that same space? Easton. Right. So let's go ahead and just put some matter in there, but not a lot. Now, liquid is more dense, but not as dense as solids. So liquid is going to have more atoms than gas. And solid is going to have the most amount of matter. So if I had a density column, go ahead, darling. Oh, plasma, it's the fourth state. So that's when matter kind of breaks apart. I would say that that would even be less dense than gas. So if we have a little density column such as this, right, we have the most dense on the bottom, and then it goes less and less and less. Beautiful density column. Just whipped that up for you last hour. All right, so let's go ahead and talk about this. If we are talking about density, I'm going to put an arrow in this general direction, and I'm going to write the word density underneath it so we can show that density is increasing. I'm going to say density, and over here I'm going to say less, and then over here I'm going to say more. Easton, are you with me? You're real squirrely, man, the last couple of days.
Yeah, I know, I'm getting good sleep.
Good. All right, so that's the basics of density. Basics of density that we need to know about. Are we good? Great. And I know you're stressed about the lab, but it's gonna be fine. All right, so let's go ahead now and look at how temperature can change density. So when we're looking at temperature and density, we're gonna look at and say that an increase in temperature makes things less dense. So I'm going to say equals less dense. We know that. So we need to start by looking at two things. We need to look at the volume and the mass. So I'm going to try to create a certain volume. I'm going to make mine 3D. You do not need to make yours 3D. You can just make a certain rectangle if you want. But I'm going to imagine that there's going to be a certain number of molecules in here. I'm just going to write, let's say, 4 of them. And I'm going to say that this is 1 cubic centimeter. But I'm going to remind us that 1 cubic centimeter equals 1 milliliter because we used milliliters when we were doing our lab. So that's 1 cubic centimeter of stuff. I don't care what it is. It's just something. All right. So when we add heat, if I was going to put heat underneath this thing with an arrow in, I'm going to heat this up. Heat is just a form of energy. So I'm going to put heat or energy in that substance. Are you with me so far? What's going to happen to those atoms when I heat them up? Yep. Yes, they are. It's just like giving you a cookie when you're 2 years old and you're going to be like, whoa, this is the best thing ever. So we're going to go ahead and I'm going to try to draw that picture again. And I'm going to show that my molecules are starting to now move fast. I'm going to put these little things around them saying, woo, I'm really moving here. So the molecules, heat makes molecules move faster. When the molecules move faster, they start bumping into each other. So I'm going to show some arrows bumping into each other. Molecules bump into each other. Now, There's a law from Isaac Newton that says for every action, there's an equal and opposite reaction. If I bump into you, you're pushing back on me. I go in one direction, you go in the other direction. So when this thing gets bumped into, it's going to send, I'm going to put dash, dash, dash. It's going to be sending itself in this direction. I need to put my more molecules in there. This molecule then is going to be moving off in this direction. So those molecules bump into each other and they spread out. So I'm going to say bump into each other and spread out. Okay. So now when we look at our cubic centimeter or our object, whatever it is, you have in that same space, now there are less molecules in that space. Now, less molecules occupy the same space or volume. This is less density. So now this object or this space is less dense. Just that certain space. And it'll rise up. In a column of air, it's like how a hot air balloon works. If you're able to have less molecules of air in that balloon because you've heated the air and the air molecules have kind of left, so you have less air now in there compared to the outside air, that balloon will rise up through the air. Isn't that just so counterintuitive? But it does. Yes, dear?
Is that why dead bodies float?
Ew. Because they become less dense. I would think it would have to be something about that. It's got to be less dense than the water, otherwise they're not going to float. Now, over time, they'll sink to the bottom because they're absorbing, they get waterlogged, and they will then become more dense than the water and they'll sink. Okay, so let's go ahead and look at this picture. This picture is describing what we have in the mantle. You need heat. Where does the heat come from in our mantle? Somebody other than Easton. Where does the heat come from? Where's the hottest place in the planet? Core. Thank you. So let's go ahead and put down here that the heat from the core, not care, core. Okay. Creates this area, and this is mantle. This is the mantle. And we get these convection currents. So the fluid, the mantle, heats up and it rises up and it begins to cool. And where is it more cool? Go ahead.
Well, I have a question. Is
Okay.
that how volcanoes are
A thing?
The heat that goes up?
Well, yeah, I mean, hot things do rise because they become less dense, but there's also a lot of pressure and there's gases in there. It's like, I don't have time right now, but imagine taking a can of soda that's sealed and you shake it, and all of a sudden you crack the top, the crust opens, and all that pressure builds, escapes. That's kind of what happens. Vicky, time. Oh! Okay, so we can't, no, you got to finish. So in the mantle, don't stop, you got to get this done. In the mantle, the core heats the magma and it becomes less dense and rises up. This drives motion of plates. There's more that I want to say, but I can't say anymore. So imagine if this was like the crust. It's pulling the crust in this direction. Hey, y'all, have a good holiday.